Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So now today let's continue on the second part of your BJT. So what have you learned previously is the intro, how the BJT works, and then you learn about the mode of operation. So we have active, saturation and cut off. And then the third part is the equation, all the basic equation of your BJT, and then your IV characteristic of your BJT relate to your mode of operation. Okay, now let's go to the mathematical part of the BJT where we will do DC analysis and we will do the load line. So we recall back what you have learned about the basic equation. So we have here the diode equation of IE, IC, beta IB, and the rest. So from these three equations, you can derive the alpha and beta. So beta must be much more larger than 1, and alpha must be almost 1, that is 0.998 or 999. So this is the third equation, IE equal IC plus IB. Okay, so for the learning outcome today, so what we're going to learn about the DC analysis of your BJT, load line of your BJT, and the voltage transfer characteristic of your BJT. So as we recall back, your diode, you also have the DC analysis and AC analysis, right? So for your DC analysis, what will happen to your BJT? Remember, we have three model, ideal model, piecewise linear model 1, and then PLM 2. So for ideal model, you're going to replace your diode with short circuit. So this is your diode. You're going to replace with a short circuit. How about PMM1? You have a diode. You're going to replace with a voltage source that we call V gamma. For the third one, the voltage source with the RF. So the whole here we call DC analysis. How about the AC analysis of your diode? So you need to replace your diode with one resistor that we call RD. What is the formula for RD? VT over IDQ. So where you can get your IDQ? From your DC analysis. And how you find the load line of your diode? So this is the IV characteristic of your diode. So you have ID here, VD here, and this is forward bias, this is reverse bias. So in order for you to find the load line, so you need to have a intercept here and then another intercept here. Connect the line of the intercept here. This is what we call the Q point. So the red one here we call load line. So this is the summary for your diode. So the same will happen to your BJT. So we also will have DC analysis, load line, but we have extra here, that is what we call voltage transfer characteristic. Okay, now so let's move to the first one, DC analysis. Why we need to do DC analysis? Because we want to determine the Q point, the operating point, so it can operate according to the application. So what is meant by operating mode? Your BJT have three operating mode. One is active, another one is saturation, the third one is cut off. So if you refer back to your IV characteristic, so this is IV. For your BJT, so this here become IC, here become VC. This is the output, right? So the shape of your IV is like this. So where is the cut off region? So here is the cut off, here is the saturation, and the rest is active. So why we need to do DC analysis? Because you're going to find the Q point. So the Q point is it either at the active, at the saturation, or at the cutoff. So if you want to make as an amplifier, so you need to make sure your Q point located at the active region. So that's why you need to do DC analysis. Okay, here I'm going to show you how to get the Q point. So this is the example of the circuit of common emitter. So why we call this is common emitter? So this is the collector, this is the base, and here is the emitter. So we look at the input and output. So here it will be your input is connecting to your base, your output is connecting to your collector. So what is common between your input and your output is your emitter. So that's why we call this one common emitter. So before we start the calculation, so the important part here is your VBE. So what is VBE? Remember between B to E, you have one diode, right? So in diode, we have V gamma. So we have minimum voltage to turn on the diode. So in your BJT, your V gamma here is become VBE on. So we call this one turn on voltage for your BJT. Okay, so now let's move to the second part. So this is how you're going to calculate your Q point of the DC analysis. So the first step of your DC analysis, so as is shown here, the circuit consists of two loops. The first loop is BE loop. This is B and E. The second loop is CE loop. CE loop. So we call here CE loop. So in BE loop, you are going to find the value of your base current, and then in your CE loop, you're going to find your value of the output voltage. How you get your IE and IC? You just need to plug in the previous basic equation that we've learned before. Okay, so I show you how the calculation will look like. Okay, so this is the same circuit. So how you're going to start? Here is what we call BE loop, and here what we call CE loop. So at your BE loop, your aim is you're going to find your IB. So let's do the KVL at BE loop. Starting from here. So look at this is clockwise, and here become anti-clockwise. So you can do both clockwise, but I really recommend you to become here clockwise and here is anti-clockwise. So you can minus VBB plus, it's a KVL, right? So RBIB plus VBE equal to 0. So you can get your IB equal VBB minus VBE divided by RB. So this will be the first equation. How you can calculate your IC? So from the basic equation, IC equal beta IB. Now you have done at your BE loop. So now let's move to your CE loop starting from here. So it's in this counterclockwise. So KVL at CE loop. So starting from there, minus VCC plus RCIC plus VCE equal to 0. So you can get your output voltage VCE equal VCC minus RCIC. Okay, so your aim of your DC analysis, you are going to find the current IC, IB. With the question 1 IE, so you need to calculate your IE equal to IB plus IC. And how are you going to calculate your VCE from the CE loop? VCC over minus RCIC. So that is the value of your DC analysis. Okay. Thank you.